I'm Alpan Raval. I'm Chief AI Scientist at Wadhwani AI, which is a non-profit AI lab doing developing AI solutions for social impact. Our charter is to create social impact using AI across the global south. And I've been working here for about 4.5 years. I lead a very talented team of about 45 AI scientists at various levels in their career. I'm a physicist by training, but I've been working in applied AI now for about 20 years. I started in this space applying AI techniques to problems in genomics and molecular biology and protein folding and so on. Then worked developing AI solutions at large internet companies. And finally, here I am trying to apply AI for social good, which is really one of the most difficult spaces in which to apply technology in general, but specifically some of the advances in AI in particular. Our aim at Wadhwani AI is to create AI solutions that will enable systems that serve people at the bottom of the pyramid, those who are far less fortunate than we are. And we are fairly agnostic to specific functional domains, although health and agriculture form major components of our work. So I'll talk a little bit now about the work we do in the agriculture area, some of the projects that we are involved in. So we started working in the agriculture space with a project that started about 3 years ago. And the project is one that automates pest management in cotton farms. As you may know, cotton is one of the largest cash crops in India, and it's dominated by smallholder farmers. It's sadly also responsible for a disproportionately large number of farmer suicides, especially in states like Maharashtra, due to these pest attacks that ravage the crop, and they completely destroy the farmer's livelihood in an instant. And this leads to suicides and so on. And you read about these in the news. So what our AI computer vision solution does is it detects and counts different types of pests that are on traps placed in the farms. So the way this works is that in a village, we select a demo farm. Usually a demo farm is a farm where the farmer can afford to install a trap and also has a smartphone. We install our app on the farmer's smartphone. The trap is placed in the farm, and the farmer has to periodically go out and take a picture of the trap where there are pests, but there are also many other things that are stuck to the trap. What the AI does is it distinguishes the pests from all of the other stuff that's on the trap, and it distinguishes between pests of different kinds, and it does a count of all the different types of pests that are on the trap. Based on this, it suggests a pesticide spraying advisory. So it either decides that there's not enough pests on the trap and therefore in the atmosphere around the farm to spray at this point, or it may find that there's already a lot of pest infestation and therefore the farmer needs to spray immediately. So this is a real-time advisory that manually takes days, sometimes weeks, to get this information back to the farmer. And in a manual process, the farm could be destroyed in the time it takes to get an advisory, whereas this is a real-time AI-based advisory. And the advisory tells the farmer when it is time to spray, as I mentioned, what pesticide to spray and how much to spray, right? What the farmer can then do is take a screenshot, go to the nearest store, purchase the pesticide, and spray it, right? This is being rolled out in several states across the country as we speak. We've already had success in Maharashtra and Andhra Pradesh with this, and we are rolling out to several other states. We are also working on extending this type of technology to multiple crops and multiple pests. The technology is somewhat data hungry because the AI needs to learn what a pest looks like on a trap. And so we need to do a lot of data collection in order for the AI to learn this. But we are also looking at other trap-free approaches to identifying infestations. These approaches include, using other signals, for example, weather signals, soil signals, and other types of data to figure out if this farm or this area is likely to have a pest infestation. And this can also, if this is used well, we haven't deployed this as yet, it's still under development, but if this is used well, then it could also guide the placing of traps on farms, and you could minimize the number of traps that you need to place. Um, Furthermore, we are also leveraging the power of some of these modern AI methods. You may have actually used ChatGPT and heard of large language models. And we are leveraging the power of large language models to build automated advisories for the Kisan call center, which is a hotline to provide information to farmers. Farmers call the call center. There's usually an expert at the other end who gives advisory information on what to sow, what the weather is like, and all kinds of agricultural practices. And what we are doing is we're working with the government and the uh, Kisan call center logs, the underlying data, to build AI chatbots, conversational chatbots, where the farmer can actually converse with the AI, get advisories, and in areas where the AI does not know what to answer, it can sort of refer back to an expert who then gets on the call. So we're looking at automating Kisan call centers, and this should be very useful for farmers. We are also working on other facets in which AI can improve farmer livelihoods, including developing spoken interfaces to create digitized farmer diaries. Farmers across the world, all across the global south, do not maintain good farmer diaries. And one of the big barriers to this is actually writing down information and so on. And if there was a audio-based way to digitize farmer diaries, which is eminently possible with current techniques in AI, the farmer can just speak into a phone. The information is transcribed into text, structured in a nice way, put it into a database that becomes your farmer diary. We are also working on AI methods for crop yield estimation and so on, but that's in very early stages. So we see various opportunities at this intersection of agriculture and AI. It's in a sense ripe with opportunities. It's also ripe with challenges, which I'll talk a little bit about in a moment. But there are these, we are very excited about this space because of various new advances that have happened in the last few months. Again, I mentioned ChatGPT as being one of the new advances, but really this ChatGPT is a special case of this area of large language models, and large language models in turn are a special case of a very ripe area in AI, which is foundation models. And these are very large generic models that have been built by large tech companies on very generic and big data sets. And they can be adapted for specific problems, like problems in agriculture, problems in healthcare, problems in financial inclusion, and so on. So there's a lot of potential there. So in the specific context of language, what these technologies have done is it's given the computer the ability to interpret language in an unstructured way. You don't need to, in the future, you will not necessarily need to have surveys. You will not, you will not need to collect structured data. You can just have unstructured text. You can have speech in various dialects and so on. The AI will be able to understand this. It's already a fair part of the way there, but it's getting better and better. And increasingly, AI will also be able to understand unstructured images and video content. Now, if used well, these technologies have the potential to do great good. Of course, they also have the potential to harm if not used well. But we are really looking at how we can leverage this to do good at the bottom of the pyramid. So if used well, then you can empower the farmer with information without requiring the farmers to be digitally savvy or even literate, right? So you can imagine systems where farmers can work with mobile phones and call an AI bot to get information, just like the Kisan call center. But you can do this in various ways. You don't have to just call. If they have a smartphone with sort of slightly more advanced capabilities, they can even get information in the form of videos. So they could talk to the bot and say, show me a video that shows me how to do X, right? Shows me how to plant this crop. Or here is a video where this is how I'm doing things. Tell me what I'm doing wrong. Now, all of this will be possible with AI models that have been trained on high quality custom data sets at the back end. So they will be able to get information in the form of audio, in the form of text. They could chat, they could do it through IVR, they could get the information in the form of videos that are customized to their locale, to their weather conditions and the time of year. Right? So this is all going to be possible in the not too distant future. You can imagine in areas where internet doesn't exist, where phone connectivity doesn't exist, you can imagine field workers armed with edge devices which are not connected to the internet, which don't require even phone connectivity, but they could be armed with edge devices that have content installed on them and that have AI installed on them that can, fish out appropriate content and then show it to farmers. And this is already happening in Africa, except that it's not AI enabled. So all of this is going to be possible with AI, where AI can select, summarize information, and so on. So you can imagine these edge devices using AI to deliver information to farmers who don't have connectivity. And you can imagine this information coming from disparate sources, including agricultural best practices, satellite data, drone data, weather data, and so on, and integrated and served to the farmer in a simple, relevant, and summarized way, and in a customized way through multiple AI tools. So I think this is where the future is. It's a potential future. There are lots of barriers to realize it. So I'll call it a potential future. I am not even going so far as to mention robotics applications that are already being used in the developed world, where you can use, where the robot uses AI to recognize fruits and vegetables, do harvesting and so on. That is probably too expensive for the global south in general. But even without robotics, there's a lot of potential applications of AI coming up in the future. Now, coming to the challenges, in general, agriculture, more so than other development areas, is a huge challenge for technology integration. Many have tried and failed in this space. Unlike areas like healthcare, there do not exist intermediaries in agriculture at scale who can translate technology into a form that is palatable by the farmer. Farmers are tired of apps. They've seen an abundance of apps. They do not want to see yet another app that they have to use for yet another function or yet another feature. This is also the reason why we at Wadhwani AI would rather integrate our AI solutions into existing systems that are already widely adopted, rather than just creating a new app or creating new systems. So this is one aspect of it. Furthermore, there's an issue of trust. AI can sometimes make mistakes. It's not a deterministic technology, it's a statistical technology, which means there is always a chance of error. And part of the AI adoption handshake involves acceptance of that error. That this system is going to sometimes make mistakes, but when it's right, it's very advantageous. Now, the problem with this is that these mistakes can turn out to be costly, specifically in the agricultural context. If you give a wrong advisory, that can lead to loss of an entire season's worth of crop, can be devastating for the farmer. In other areas like healthcare, there is usually a doctor in the loop to correct any errors that are made by the AI. But in agriculture, it's very difficult to scale that model up. So building trust in AI technology is going to be time consuming. It will require extension workers in the loop who are trained to use the technology, who work closely with farmers, get farmers familiarized with this. And so there is a long time, I think there's a long time that it will take to develop trust. The third aspect is agriculture has highly localized problems. What is a big problem in one part of India or for one type of crop may not be a problem for another type of crop or in a different part of the country or a different part of the world. And so any tech solutions that you build also need to be highly localized. And this tends to be a bit of a challenge for AI, although it's getting less so, because developing AI needs large data sets. Now, if you're going to build models that are very, very localized, typically the models the data that goes into these models will also be localized, and therefore almost by definition be small data, whereas AI typically needs big data to be accurate. So these are some of the challenges. Some of them are already being addressed through research that's being done. But the challenges do exist, and I think it will take a while for AI to be widely adopted in agriculture. This is an area where digitization and technology in general is weak. Um, so now one of the questions is how would this intersection between AI and agriculture evolve going into the future? And this is something that is often asked, and it's a tough one, really. Uh, I think the way this will evolve will be different in the global south as opposed to the developed world, for some of the reasons that I've already talked about. In the developed world, in the US and Israel, one can expect to see tech saturation fairly soon. The reason is agriculture is already largely industrialized. You have large industrial scale farms. It's relatively easy in these farms to integrate tech, robotics, AI, and because of economies of scale, because these farms are so big, the risk appetite for errors and failure, technology failure, is also much greater. In smallholder farms, the risk appetite is absolutely nil. You can't go wrong. If you go wrong, you're destroying a farmer's livelihood. So these are all open questions. How AI will develop in this area is very dependent on what is the future of smallholder farming. That's a critical question. I'm certainly not an expert on that. But also there's the larger question of how well methods for data capture will evolve. I mean, the field of AI will continue evolving on its own, but AI hinges on data. Data capture is going to be critical. Will we be able to capture soil conditions accurately? Will we be able to predict weather accurately? Because all of this feeds into AI models and influences the accuracy of AI models. And the trust in AI is intimately related to accuracy. Right? So it's a complex, it's too complex to predict what exactly is going to happen. But I think the relevant questions are really these. How do we get better data capture? How can we get better weather predictions and get this information to where it's needed? How can we empower smallholder farmers with the new tech while at the same time insulating them from its risks? I think there's a lot of uncertainty around some of these issues, so it's hard to say how exactly things will go. But I think it's clear that a lot of experimentation, a lot of pilots need to be deployed first to make AI solutions stick and to figure out which types of AI solutions will stick. I don't think that's been figured out by anybody yet. Lastly, a few words around policy. Again, I'm not a policy expert, so not too much to say there, but one advantage I think that agriculture has in terms of technology adoption is that there are fewer data privacy issues as opposed to other areas, although they're not fully absent. And one of the big policy questions around AI in recent times has been around data privacy. So I think this is not so big in agriculture, except where it comes to areas like models of financing that may depend on the economic conditions of the individual farmer. There's also other areas like crop insurance and so on where data privacy issues may be important. So I can imagine sort of a doomsday scenario where crop insurance companies have access to huge amounts of data, not just about the farm, but also about the farmer. And if that access is given, they could presumably build models that are unfair to farmers and use them for insurance. And this is not the kind of outcome one wants. So I think that is where policy will need to step in to, for example, control the kind of data that is accessible to insurance companies. On the other hand, we have to ensure that the relevant data gets last mile dissemination to the farmer. And the question is that something we can codify in policy? And these are some of the basic policy issues that I can think of. So I'd like to end there. In general, I see a lot of opportunity, not without its challenges. I see this taking time to play out. I think AI in agriculture will take longer to play out. The challenges will be harder to overcome than in other areas like healthcare, financial inclusion, and so on. But I think it will be worth the effort. Any effort where you can empower a farmer with information that's relevant to what they grow, and that they cannot easily get anywhere else, is going to be very important for their livelihoods. And I think AI has the potential to do that. Thank you.